Hello, Camille. Here we are at number 4. And in this particular problem, looks like you have to factor again. And instead of having a quadratic or an x squared term, you have x to the third power or an x cubed term. So you have to figure out what you're looking at here. And we only have a binomial here. We don't have a trinomial to factor. And so this is obviously looks like a difference of cubes. So I don't know if you're familiar with this term, but difference of cubes, meaning that I have two perfect cubes, two cubic terms that are I could take the cube root of, and they're basically separated by subtraction. That's why it's difference. Okay. If it was the sum, it would be addition. All right. And so I take basically the cube root. Okay. I take the cube root of both of these terms. So the cube root of x to the third power is just x. And the cube root of 8, okay, you might not know that off the top of your head, but you kind of got to be familiar with at least the basic, like your basic perfect cubes, just like your basic perfect squares. So that equals 2, because 2 times 2 times 2, 2 times, I should put it, a dot, 2 times 2 times 2 is 8. So anytime you have 3 identical factors, that's a perfect cube. Okay? All right, just like this over here would be x times x times x. Okay? Equals x to the third. All right. So we take the cube root first, and that's why he was like, just take the x term in his video and then take the cube root of this, right? And that's what you're going to put in your first set of parentheses. Now, here's what you need to realize. He said do a short set of parentheses, and then he said do a long set of parentheses. In the short set of parentheses, you're going to have a binomial. In the long set, you're going to have a trinomial. Well, whenever you factor out a cube function, okay, it's something that's raised to the third power and that's the highest exponent in the problem. 9 times out of 10, if not every time, you're going to have a binomial times a trinomial, okay? One of the terms is going to be regular x, one of them is going to be x to the second power. That's most cases, okay? So if we're looking at this, you take the cube root of the original term and you put it here. So we got x right there, and then we got 2 right there. Now, is that a positive 2 or a negative 2? This is where the SOAP method comes in. This is the way he remembers his signs, okay? So the S stands for use the same sign as was originally here, right? So there you go. You're going to use that sign right there, okay? And, of course, the 2 goes here as it is. So you don't have to worry about whether the 2 is positive or negative. You use the same sign as here, okay? And then the opposite, I believe you said same opposite, pray for me. Same opposite. So the opposite, so in other words, there's going to be 2 signs or 2 operations in this big set of parentheses here. There's 2 operations because you have 3 terms and they're separated by 2 operators. So they're either going to be positive or negative. And so the first one inside the parentheses is going to be the opposite of what this one was. Okay, it's going to be the opposite of that one. So we know the opposite of negative is positive. Okay. And then I forgot what the A was. Oh, always positive. They go together. So these 2 actually go together. So always positive, the last term is always positive. You're never going to have a negative term on the last. Okay, from what I understand. So how do we figure out the 3 terms that go in these gaps? Here, here, and here. Okay, so he says what you do is, so I'm basically done with SOAP. Okay, the SOAP is only for the signs. Okay, to determine positive or negative signs for those three signs. Now I have to determine what are these three terms here after I've figured out the x minus 2 part. Now I take the first term, which is the x, right? The x, or here, this is where he's coming from, right there, and I square it. So let's go ahead and do that. X squared, okay? Then we take the second term. Well, before you do that, actually you square that, and that goes in the last, right? But the middle term comes from multiplying x times 2. And when you multiply x times 2, you never put the x first, you put the number first. 2x. That's it.